All right, we're going to explore one last exercise on this solving equations section. And this is actually specifically at the request of one of the electronics faculty members here at the college. So I decided to add this thing in there just so you could see yet another way in which we solve equations and see some of the ways in which things can be a little bit different. So there's this idea in electronics of what we call circuits with resistors in parallel. And there's a little picture of what that sees, not to get too technical on this, but basically you have two different separate branches through which the current is flowing, and they have two separate resistances there. And the way that you combine resistances with one of these circuits is not necessarily the way you might think that you would do this. You can get into more of this if you take more electronics, but we're just going to get right into the equation and work with that. Our total amount of resistance is given by this equation, that 1 over the total resistance is found by adding 1 over the first resistance plus 1 over the second resistance. There's a bunch of ways we could solve this, but the easiest way that gets the least technical amount of work in here is to do the following. If we want to find the total resistance, we can plug in our values for each of those resistances, and then we want to go ahead and take what we call the reciprocal of both sides to find that total amount of resistance. So let's say we want to find the resistance, the total resistance in a circuit where we have two resistors that both have 330 ohms of resistance. Well, taking this equation that we have here, we can plug in 1 over our total is equal to 1 over 330 plus 1 over 330. So if we add that, again, we can do this with just a straightforward calculator. That's fine. You can note, if you're being clever with your fractions, remember that when you have two fractions that have the same denominator, you can just add across the numerator. 1 plus 1 is 2 over 330. But if you don't feel like doing that, you don't have to. In fact, a lot of the numbers won't work out very nicely, so we might as well use a calculator. So we add 1 over 330 plus 1 over 330, we get this quantity in here. Now, what we want is we want to find the total resistance. So we want to find our total itself. Right now, what we have is 1 over the quantity that we want. So that's what we call the reciprocal. If we want to find our total itself, then what we're going to do is take 1 over this quantity that we just found. So 1 over this quantity, 2 over 330. Well, dividing by a fraction is the same thing as multiplying by the reciprocal, or probably the easier way to think about this. We're just going to take 1 over this number. I'm going to go ahead and do that 1 over. Let me go ahead and do second answer. So in my calculator, getting that second answer key will allow me to directly call upon that number. No need to round it intermediate steps and lose accuracy or anything like that. If we go ahead and do so, we will get 165. And of course, the units here are the same as the units we just saw above. That will be in ohms. And curiously, actually, if we think back to this, remember the reciprocal. So the reciprocal of a number, 2 over 330, excuse me, is just what we get when we flip that fraction upside down. So it's 330 over 2. So curiously, when you have two resistors that are both 330 ohms and you put them in a circuit like this, the total amount of resistance actually works out to be half of that. So half of the amount of resistance in either one, a total of 165 ohms. Now, let's look at this example, do another one, except change it up a little bit. Suppose instead of 330 and 330, we have 110 with 330. Well, the first step's going to work exactly the same. 1 over the total resistance is going to work out to be 1 over 110 plus 1 over 330. And again, we can go ahead and just use our calculator for this part. No need to worry about simplifying fractions by hand. If that's your thing, by all means, feel free to do so. You add that stuff up, you get this weird repeating decimal. That's fine. So then, to find the total resistance, we're going to take the reciprocal of this answer that we just found. So if we go ahead and take the reciprocal of, I'm going to write it as 1 over 0.012, etc. And I'm just going to write that part down, not because I want to round, but actually just because it's keeping it straight on like what exactly it is that I'm doing here. I'm trying to find the reciprocal of this value that I just found at the previous step. Again, just to make it kind of clear where all these numbers are coming from, that this quantity is this 0.012 and so on and so forth. So when we take the reciprocal of that quantity, so again, 1 divided by my answer, I get 82.5 ohms out of that. And if those were exact amounts, then we could report that with the exact amount. Or if we round, so we'll express our answer both ways. If we rounded to, note both of these numbers have 2 significant digits. So if we rounded 2 significant digits, then that would give us the result of 83 ohms. And again, there are sort of standardized values of these resistors, and that they're only accurate to about 1% either way anyhow. So last example, let's suppose we stepped it up. So if we had another part to this thing, so if we threw in another resistor, I'll just kind of add it to my picture up here. If I added another resistor so that there were now 3 resistors in total, well, on the one hand, it's going to get more complicated, but the process is actually going to work out exactly the same as what we just saw. If we have 3 resistors in parallel, the way we find total resistance is, again, 1 over the total resistance is found by adding up the reciprocals of each of those resistances. So let's find our total resistance if we have these 3 values for my individual resistors. Same exact math that we're going to do here. 1 over the total resistance is found by doing 1 over 130 plus 1 over 210 plus 1 over 330. And again, no need to do all this stuff by hand. In fact, here's where it gets really crunchy if you try to do all that stuff by hand. So instead, let's just use our calculator to figure out what is that right-hand side of the equation. When I add up all of those numbers, I get this number that works out to be something like about 0.01548, etc. Again, that quantity is not the quantity that I want. It is the reciprocal of the quantity that we want. So the way that we find the total resistance is we take this number that we just found and we do 1 over that number. So whatever it is, 158, etc. 1.48. Again, that number already stored in my calculator. No need to round. In fact, if we do round, we probably will lose accuracy. So instead, we use the exact number as it was given before. We here get a kind of crunchy number, crunchier than the ones that we saw before. Same idea here, right? With those values that we were given, we are going to go ahead and round. We see 2 significant digits. So if we round to 2 significant digits, we will report that value as being 65, and resistance being measured in ohms. So that's the process for how we find the total amount of resistance for one of these things in parallel. Again, good chance you might see this in one of your classes, depending on what sort of math you do. But there's a lot of other things that have the same sort of relationship. So thinking about things in terms of reciprocals will help us a whole lot moving throughout this course. All right, take care.